Hi, I'm Scott Gerben, Crane Application Engineer for Siemens Industry USA. This is the fifth and final video introducing Siemens SIMOCRANE Basic Technology V5.0 for the SINAMICS S120 platform. This video will cover setting up a single master hoist with a single slave hoist. Now that we have covered setup for most of the commonly used blocks, it is time to discuss how to set up a master and slave hoist within BT V5.0. To start, you need to have a master and slave hoist inserted into your starter project as shown. From here, import the BT Basic Hoist Master and BT Basic Hoist Slave DCCs into each respective drive. Note that these DCCs are intended for use with the basic license of SIMOCRANE Basic Technology V5.0. This means that these DCCs are designed for use on mechanically coupled torque sharing hoists that do not require speed synchronization or position synchronization. If advanced license functions, such as position or speed synchronization, are required, you should double-click the BT Basic Hoist Slave DCC and insert the Synchron control block from the LCR BT library in CFC Editor. Please note that a CFC Editor license is required to add this block. See the description below this video for instructions on acquiring a CFC Editor license. Once this block is added, you must change the block name to SCC in order for the script to recognize the Synchron control block during script setup. Once this DCC is recompiled as necessary, you can begin the script setup starting with the master hoist. During script setup, it is crucial to run the script on the master axis first in any master-slave configuration. This is due to the way that the script makes interconnections between the master and slave blocks. First, you must define which available axis is the master's slave axis on the initial script screen. Once completed, you can set up most of the blocks on the master hoist the same as you normally would, with the exception of the main drive block. The first new input you'll see is the master mode input. This input should be set high when the master hoist is intended to act as the master to the slave. If the master will always be a master to the slave drive, set this input to 1. If mechanically coupled hoists are being used, you should set the EN torque control input to 1 to always enable torque control between the master and slave hoist. The remainder of the master hoist can be set up as described in previous videos in this series. Links are provided in the description below. Once you've successfully set up the master hoist, you can start running the setup script on the slave hoist. Similarly, you should start out by selecting the master hoist as the master to your slave hoist. Next, be sure to select synchronous control if you will be using the speed or positioning synchronization modes between the two drives. Once again, a reminder that a CFC Editor license is required to add synchronous control. See the description below for instructions on acquiring a CFC Editor license. Similarly, you'll need to configure the slave mode input of the slave's main drive block to configure the drive as a slave drive when desired. Additionally, you should configure the EN torque control, EN speed sync, and EN pause sync main drive block inputs, as they are necessary to configure which type of mode the slave should be run in. Note that only one slave mode is possible at a time. Once the main drive block is configured, any other blocks should be configured as covered in previous videos until the SCC block is prompted to configure. This only applies if you inserted the SCC block onto the slave hoist or are running this on the BT ADV Travel Slave DCC. Next, taking a look at the synchronous control block diagram, you can see the main block inputs and outputs. The synchronous control block is used to achieve synchronization between a master and a slave drive. An existing offset can be aligned, or a desired offset can be specified and maintained. During script setup of this block, you will be asked first to configure the Enable Master Reduce Boolean input. This input will enable the master to slow down if necessary to help maintain synchronization with the slave drive. If this input is set low, then the slave drive will exclusively be responsible for maintaining speed and position synchronization with the master. A position offset can then be specified for the slave drive in millimeters at the offset position in input. The maximum offset speed that the slave may deviate from the master in order to maintain synchronization should be specified in offset speed in. It is important to provide a value other than 0% here, as a value of 0 will not allow the slave to maintain position synchronization with the master hoist. The positioning accuracy input in millimeters, as well as the KP constant for position synchronization, can also be specified on this screen. However, the default values are recommended during initial commissioning. Set positive offs speed and set negative offs speed can be configured to manually offset the slave drive by the speed parameterized in the offset speed in input as well. Additionally, the align offs position input can also be configured to enable alignment control when utilizing position synchronization between the master and slave drives. And finally, for the SCC block, you can also configure the master move off speed and the delay time offs align inputs. Once the SCC block has been set up within the script, you should be able to complete the rest of the script as previously described and test the master and slave functionality as shown.
Okay.
Now you're ready to utilize the scalable master and slave functionality included in SIMOCRANE BT V5.0. If you'd like more information on SIMOCRANE BT V5.0, a good place to start is usa.siemens.com/cranes.